We are going to discuss about the simplex method in operation research. So this is a sum where maximum z is equal to 3x1 plus 2x2, which is considered as an objective function. And subject to constraint is x1 plus x2 is lesser than equal to 4, x1 minus x2 is lesser than equal to 2. So this will be considered as a subject to constraint. And x1 comma x2 which is greater than 0, which is a null constraint. So the first step in simplex method is, first we have to introduce about the slack variable. What's the meaning of slack variable? Is nothing but it is a dummy variable. That is, here the subject to constraint we have to convert it into the equation form. So in order to convert this equation form, we have to introduce the slack variables. So according to that condition, the equation will be considered as maximum z is equal to 3x1 plus 2x2, and the equation will be x1 plus x2 plus s1. So that is equation number 1, introducing the slack variable, which is equal to 4, and the value for s1 will be here 1. So the next subject to constraint will be converted as x1 minus x2 plus 2 s2, that is second equation with slack variable, and the value will be also 1, which is equal to 2. So this is the condition. So what are the variables we are what are the things we are introduced in the subject to constraint, that is in the equation? It should be mentioned in the objective function. For example, if I am introducing the slack variable 1, I have to mention in objective function, and the value will be 0. For second equation, I introduced s2 as a slack variable. Here also I have to mention as 0 s2, because the value for objective function should be 0. So the next condition here is, in case of objective function, what are the elements? It should be mentioned in the null constraint. So accordingly, x1, x2, s1 and s2 it should be greater than 0. So the next step here is we have to convert into the matrix form, which I already wrote. So in case of matrix form, the variables are x1, x2, s1 and s2. So the condition is, for x1 the value will be 1, and x2 the value will be 1, s1 the value will be 1. The same thing I wrote here, but in case of equation number 1, there is no s2, so I marked as 0. And the second equation is x1 is 1, x2 is minus 1, which I already wrote here, and s1, here there is no s1 in subject to constraint for the second equation, so I marked as 0, and for s2 the value is 1. And this set of variables should be multiplied with the constraints like x1, x2, s1 and s2. That's why x1, x2 and s1, s2. So if I multiply the values with the x variables, I am going to receive this one. That is, after equal to, the value will be 4 and 2. 4 and 2. So this is about the matrix form. Thing is, the entire matrix form is to be converted into the table form. Here we have the variables like CB, B, XB, X1, X2, S1 and S2. So we know about the what's the CB. CB is nothing but the slack values. B is slack variables. That is, here we had introduced the slack variable as S1 and S2. So the values will be S1 and S2. So the value for S1 is 0 and for S2 is 0. So CB is slack values, so I mentioned as 0. So what's about the XB? So XB is nothing but the values which is after the equal to. So 4 and 2. So the values here, it should be marked here. So x1 will be 1 and x2 will be 1, s1 is 1 and s2 is 0. So that's the same thing here in matrix I mentioned here. So here in x1 is 1, x2 is minus 1, there is no s1, so I am putting 0, and s2 is 1. So And the next concept here is, we already mentioned that x1, all these things I mentioned here after equal to, the values I mentioned here, x1 x2 variables I mentioned here. So what's the thing here I have to mention is, regarding the objective function is missing. So objective function for x1 is 3, x2 is 2, s1 is 0 and s2 is 0. So the next step here is, we have to find out the Zij minus Cij. So for finding the Zij minus Cij, we have the formula like Cb into x11. That is, Cb should be multiplied with x1 along with Cb, second row, should be multiplied with x2. And the same thing is Cb into x12. So minus objective function, that is Cb should be multiplied with x1. This is the format. Zij minus Cij, that is Cb is 0, which should be multiplied with x1, and plus Cb should be multiplied with x12, along with we have to deduct from the objective function. So let I draw for x1, like Cb will be 0, which should be multiplied with x11 is 1, and plus Cb2 will be 0 into the value for x12 is 1, minus, according to the formula we have to mention a subtraction or a deduction, and the objective function of maximum for x1 will be 3. So accordingly I am receiving as the value of minus 3, that is 0 into 1 is 0 plus 0 into 1 is 0 minus 3, I am receiving as minus 3. Like this we have to follow the same step. For x2, let I find out for the x2, the Cb will be 0 into the x12 is 1 plus Cb is 0 into x22 is minus 1, and minus the objective function will be 2. So accordingly I am receiving the value as minus 2. So the same step we need to repeat and find out the value for s1 and s2. Accordingly I am receiving as s1 is 0 and s2 is 0. So the next step is, we have to select the minimum value of Zij minus Cij, which is considered as a withdraw value. So here Zij will be minus 3, minus 2, 0 and 0. The lower value will be minus 3. So just I am introducing. What the thing is, I have to mark. So this is the withdraw value. Next concept regarding the simplex method, the next step is, we had selected the column wise, that is the withdraw value. Accordingly we have to find out the row wise, which is exact row is going to miss. So for that we have applied the formula minimum xb divided by withdraw value. Here wb is withdraw value. So here the xb is regarding the table we have 4, 2, and the withdraw value for x11 will be 1 and 1. Let I show. Here this is the withdraw value for x11. The xb is 4 and the x1 is 1. Here xb is 2, x1 is 1. 2 is 1. So accordingly we have to divide and find out the value as 4, 2. So the condition here is, we have to select the minimum value. So accordingly we are selecting the minimum value. So while how we have received this 2, it is the second row, that is the value of xb is 2 and the x1 is 1. So I am receiving the 2, which is the second row. So I am selecting row 2. 2 is 1. So accordingly we have to divide and find out the value as 4, 2. So the condition here is, we have to select the minimum value. So accordingly we are selecting the minimum value. So while how we have received this 2, it is the second row, that is the value of xb is 2 and the x1 is 1. So I am receiving the 2, which is the second row. So I am selecting row 2. Row 2. So just I am marking, that is I am selecting row 2. Yeah, I had selected. So here, what the next thing is, we have to find out which is the common circle. So here, this will be the common circle. Okay. So what the thing is, I had to, which value I had been selected, that should be converted into 1. For example, if I am having 4 here, how I am going to convert? By dividing the same value. So here the concept is, I am dividing the same value of the selected cell with other cells. And so I am dividing along with here. So the value 1 had been divided with remaining row values. Selected R2, which is the withdrawal value, by applying this formula. After this step, we need to prepare a new table regarding the same variables like CB, B, XB, X1, X2 and S1. So it is in simplex method. So we are withdrawing the S2 value, S2 variables which we had introduced. Then we have to mention the objective functions. For x1 the objective function will be 3, for x2 the objective function will be 2, and for s1 the objective function will be 0. Here the thing is s1, which is not withdrawing, and for that s1 we have the CB value as 0. So accordingly the rule is we are selecting the row 2, that is the x1 table. We came to know that -3 is the lowest value. According to applying the formula, we have selected this intersecting line. So then the value of S2 in new table should be changed as x1, and at the same time the CB value, which is the objective value, is for x1 we have 3. That should be mentioned. And at the same time we know that the intersect value should be converted into 1. That is, for example, if we have 4, that should be divided with the same 4. That is, the same way the value should be divided, so that we are able to get 1. And the divided value should be applied in all the things. So for example, if we have 2 and here the division is 1, so 2 divided by 1. Here -1 is divided by 1. 0 divided by 1. So on the base of this we are creating a new table. By dividing the 1, we are receiving these values like 2, 1, -1 and 0. After this we need to find out a new table value for row 1 by applying the formula. The condition should be is, what are the intersect value? The above should be 0. So this is the condition. So how we are going to create a 0 is from the old table, that is old table value plus the common factor. So common factor here is, in case of old table, the value which is converting as 0, it should be considered as a common factor, and it should be multiplied with new table value. So accordingly the x1, for x1 we have the old table value as 1. For xb we have the old table, that is the previous table, is 4, and for x2 we have the previous value as 1, and for s1 we have the previous value as 0, which should be added. And this 1, because here the x1 only we are converting as 0, so that 1 should be considered as a common factor by changing the symbol. So here the positive 1, it will be converted as negative 1, which is the common factor. And the new table, that is the table number 2, we have x1 as 1, and xb is 2, x2 is -1, and s1 is 0. So accordingly, if we multiply, that is -1 into 1 is -1. According to the Bodmer's rule, we have to first simplify in the bracket values. So -1 into 1 is -1 plus 1, we are receiving 0. Here it is -2 plus 4, we are receiving as 2. Here it is minus 1 into minus 1 is plus 1. So plus 1 is 2. Here it is 0. So for x1, the condition we are satisfied, that is it should be 0. So we had received 0. For xb we have 2. For x2 we have 2. S1 we have 0. So we have framed the new table. After this, we need to find out, as usual, we have to find out the Zij minus Cij. So the formula for Zij minus Cij is Cb into x11 plus Cb into x12 minus objective function. So accordingly, x1 is, the Cb is 0 into x1 is 0 plus Cb is 3 into x12 is 1 minus objective function is 3. So we are receiving as 0. For x2, Cb is 0 into x11 is 2 plus Cb is 3 into x11 is 12 is minus 1. Then the objective function is minus 2. So we are receiving as minus 3 into minus 2 is minus 5. For S1, Cb is 0 into S1 is 0 plus Cb is 3 into S1 is 0. Objective function is minus 0. So automatically we are receiving the 0. So we had found out Zij minus Cij. For S1 it is 0. For x2 it is minus 5 and S1 is 0. So what's the condition? The next step is we need to find out which is the withdraw value. So accordingly, the Zij, which is the highest negative value, will be considered as the withdraw value. So here the minus 5 is considered as the withdraw value. So the next step regarding here is by applying the same formula, that is minimum xb divided by wv. Wv is withdraw value. So minimum xb divided by withdraw value. So here the xb is, in new table we had 2 comma 2, and the withdraw value here is x2. So here we had 2 minus 1. So the condition here we have to note it is the negative value should not be selected. That is the main condition. So accordingly we have while dividing we are receiving as 1 minus 2. So here the minus 2 should not be considered. So we are selecting 1 because minus 2 will be considered as a penalty value. So we are not giving importance to the penalty value. So 1. So accordingly the row 1 we had selected. So row 1 I am selecting. So on the base of this, the next step is we have to divide the same value to get the 1 in the intersect value. So here the 2, so we are dividing with the same value as 2. So 2 and 2. So automatically it moves for the next table. In this regard, in creating a third table, we had to withdraw the S1 because in from table 1 to table 2 we are withdraw the S2, and table 2 to table 3 we are relieving the S1. So accordingly we have to convert this 0 as an objective function of x2 because it is a withdraw value. So x2 we have the thing as 2, that is the value as 2. So now we are going to create table number 3. Writing this I had received the x1 will be 0 and x2 will be 2. So the intersect line for these things are x2 here. The intersect line is x2, that is the minus 1 should be converted as 0. So the x2 should be 0. So for finding that we have to make a comparison, that is old table plus common factor into new table value. Here the old table value for x2 will be minus 1, that is from the table 2 it is x1, and for x1 the old table value will be 1, and for xb the old table value is 2, which should be added. And here we are converting the x2 as 0. So here we are converting the x2 as 0. So the value of the old table of x2 is minus 1, which will be converted as a common factor, that is the minus 1 will be considered as a plus 1, and it should be multiplied with the new table. So the new table value for x2 is 2, x1 is 0, and xb is 1. So we are value for x2 is 1, x2 is 1, x1 is 0, and xb is 1. So accordingly we are receiving a 0, here it is 1, here it is 3. So 0, 1, 3, just I had applied. So here the b will be, what's the withdraw value? The withdraw element will be x1, and the value for x1 or an objective function is 3. So as usual, the next step is regarding, we have to find out the Zij minus Cij. The formula is Cb, which should be multiplied with x11 plus Cb2 into x12 minus objective function. So accordingly we have 2 into 0 is 0, plus 3 into 1 is 3, minus objective function is 3, so I am receiving 0. The same condition for x2, 2 into 1 is 2, 3 into 0 is 0, minus 2, that is 2 minus 2 is 0. So automatically we had received all the things in Zij is positive values. So as we received all the Zij minus Cij variables for x1 and x2 is positive, so we had received the optimum solution. So how you are going to find out the optimal solution is by applying from the objective function, that is maximum z is equal to 3x1 plus 2x2. So here the x1 value is objective is 3. So x1 will be 3 and x2 will be 2. So just apply here, that is maximum z is equal to 3 into 3 plus 2 into 2. So 9 plus 4, which is 11. So this is the maximum objective, that is on the base of 11 we receive the optimum solution. And at the same time we can make the verification whether our step is correct or not. The formula for that is Cb into Xb. So accordingly the Cb value is here the Cb value is 2 and the Xb is 1. So 2 into 1 is 2. Here it is 3 into 3 is 9. So 2 plus 9 is regarding 11. Received the optimum solution as well as the verification we have received as 11. So we are finally we have received the optimum solution. So this is regarding the various steps of simplex method. Thank you.